Welcome back to Periodic Properties of the Elements. This is exciting because this is one of those core things that we learn in chemistry, and that's how to predict the electron configuration of atoms and ions. And in this part, we're going to do the atoms themselves, and we're going to apply the Pauli exclusion principle, the Aufbau principle that we just learned, and Hund's rule to electron configurations. So I've got your summary slide here for you to look at. Orbitals fill in the following order, and I have that order listed for you. Okay, now you can memorize that, and you got to remember that there's 2 can go in S, and 6 can go in P, and 10 can go in D, and 14 can go in F. And if you can memorize that order, then you're good. Because notice that you get up to 4S here, and then all of a sudden you go back down to a 3D. And that's because of that degenerate energy that I was talking about earlier. So it'll throw you off if you don't, remember it exactly. All right, energy levels and sublevels fill from lowest energy to highest energy. So they're going to go S, P, D, and F typically. That's your Aufbau principle. There can be no more than 2 electrons per orbital. That's Pauli exclusion, so that's why we only put up to 2 electrons in each one. Now, this third one is very important. Hund's rule. When you're filling orbitals with the same or degenerate energy, for example, 2p here, you've got to put 1 electron in each one before you can pair them up. So if I was, this is the one for carbon, but if I was doing something that had more electrons in it, I would put another electron there before I doubled or paired up electrons, okay? And then I would go on and pair the rest of those if it was full. Okay, because you got to have enough electrons to do that. So if I was going to do this configuration right here, then I would have to have 10 electrons. But the point is that I've got to do 1 in each one of those before I can pair them up. That is Hund's rule. All right. And then the last one is orbitals can hold no more than 2 electrons each, right? So no more than 2 electrons each. That's Pauli, but you got to remember it, okay? Now, I told you that it's going to fill an increasing energy level. And so this is a graphic of an orbital diagram, okay? The orbital diagram shows you that you're going to fill down here with 2 electrons, right? Before you put any up here. Then when you fill the P, you're going to do 1, 2, 3, don't forget Hund, 4, 5, 6, and then it'll go to the S, because you can't go up there until you do that, okay? And then when you get up here, notice that they're a lot closer together. And so that's because some of these overlap. And if you remember, D's have a lot of lobes. And when you get a lot of lobes where the electron could be found, it kind of almost overlaps with the P's. So that's why you have a 3D before you have the 4P. Okay, so that's why we write it like that in that order. Now, for me, an easier way to remember this is something you may have learned in high school. Okay, so we're going to think back on that chart where we learned how to do the order, because the order is really the only hard part of this. All right, so remember in n equals 1, you could have an S. Then when you got to n equals 2, you could have an S and P. Then n equals 3, you could have an S, P, and D. And then n equals 4, you could have all 4 of them. All right, so and then in the pattern, you're going to still, with n equals 5, be able to have S, P, D, and F. And then you're going to go back down. When you get to 6, you can only have S, P, D. And when you get to 7, you can have S, P. See how that works? So if you can remember that, then you write 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. Then repeat that, 5S, 5P, 5D, 5F, and then go back down. Okay, so that's the pattern. And then what they're showing you with these arrows is you go back to the beginning and you do an arrow. And so the order is 1S, and it can hold 2. And then 2S can hold 2. And then 2P6, 3S2. And then 3P6, 4S2. And then this is where it goes back to the 3D10, 4P6, 5S2. So if you can remember this and just draw it, then you can remember how they feel. And you don't have to just memorize the other one, because this is just the pattern. All right, so this is one way of doing the correct order for your electrons. You can also do it by looking at the periodic table. Okay, so if you look at the periodic table, you have, this is 1s1. I'm doing it with the 1, right? So then this, so 1s1, 1s2. That's the only one that's a little sketchy. Then you get to the 2. So this would be 2s1, 2s2. Then notice that there's 6 over here. So this is 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Come back 3s1, okay? And then go across 3p1 to 3p6. Then 4s2, and then 3d10. You just have to remember that you go, since this goes down, you go down one number to do 3d. So this is, so that's 4s1, 4s2, 3d1, 3d2, etc. to 3d10. And then you're back to 4p1, okay, to 4p6. And then 5s1, 5s2, 4d, right? Now, when you get to the 6s, remember that you go down. So then you're going to do, and then you go down 2 numbers to 4f1 through 4f14, right? And then back up to 5d1. Okay, so remember, you can stop this and go back and play this over and over again if you're not quite catching this. And I'm going to show you an example of doing these as well. Okay, so we're going to do calcium first. So we look at calcium, and calcium has 20 electrons. How do I know that? Because it's number 20. Its number is 20, so that means it has 20 protons and 20 electrons. So once I know how many it is, I have to know what the order is for the electron configuration. So you can use either method. You can look at the periodic table and do it. It's only got 20 electrons, so it won't even get into the D's, okay? Or you can, memorize it, or you can use the arrow method that I showed you before, okay? So whatever method you do, you're going to write that down. 1s, 2s, 2p, 3s, 3p, 4s, All right, now you could keep going because we know the order. The next one would be 3D10, right? But I don't think we need it because I know that I can have 2 and 2 and 6. That's 10. And then I can have 2 and 6, which is 8, and then 2 more, and that's 20. So that's the electron configuration for that. If I was doing the orbital diagram, it would be 1s, 2s, 2p, 3s, 3p, 4s. And I'm not a super stickler on that you get that, you know, get them exactly right in the right level. You can do them all level together. So that'd be 2 in that one, 2 in that one, 1, 2, 3, 4, 5, 6 in that one, and then 1, and then there's your 20 electrons with your 4s up there. Okay? All right, let's do iron. So once you've written them, you just write that again, 1s, and you can count electrons as you go, or you can just write them out. 1s, 2s, 2p, and again, I know them because I do it a lot, but you can go back and look at whatever your little cheat scenario is. So after 4s, I'm going to do a 3d. Okay. Now, iron is number 26, which means it has 26 electrons. So once I do my order, I'm going to say 2, 4, 10, 12, 18, 20, and I know that from up there. And then iron is going to have 6 more, and I could have up to 10 in this D, so I just do 6 because it doesn't fill it all up because it only has 26 electrons. And so again, you just draw the, if I wanted to do the orbital diagram, that's what this is, and this is the electron configuration. And it's just 2 different ways of doing it. The next one's kind of crazy. It's 53. Okay, so I'm going to have to know my order pretty far out. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p. I think that's enough. But you could keep going, right? Because you know the pattern. All right. So I've got 2, 2, 6, 2, 6, 2. And remember, I know that's 20. And then 30, 6, 38, 48, 54, 56, plus 14 is 60, I think. 70. No, not 60. 4D. Oh, wait. I went too far, didn't I? See, I do that sometimes. So 40. So this was 30. 48. Whoop, yeah, 48. 54. 54. So I should have stopped here with a 5p 5. Sorry, I get carried away because I think this is fun. I know I'm a nerd. So it should just be 5p5 at the end. All right. Oh, lead. Lead's big. Okay. Lead is 82. 2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. Now I get to do a full 5p. Then I go 6s to 4f14, 5d10, and 6p2. Whoa, I went way up. So look, I went up the molehill. Sorry about that. Okay, so as you're doing this, like, you go back and check yourself and make sure that you're doing the right order, because that's super important when you're doing it for an exam or homework or something like that. Okay, so again, you've got either the periodic table way of remembering the order, which is, I like it because it's visual, I guess. You've got the arrow way of doing it, or you got the memorizing way of doing it. Okay, and so again, it's all about the patterns. We probably won't go much past the 6p. Okay, we're going to do this, I think, here maybe in a little while, but while I'm doing this, I just want to show you one thing. If I ask for the shorthand of this, you can do something that makes it a lot easier on your carpal tunnel for your hand. Like for this last one for lead, since it's got so much, only if I ask for shorthand now, because you need to know how to do the full thing. You go back to that column 8A, and that's called the noble gases, and they are a full p orbital. They're a full p6 orbital. You can go back to that one, whichever one it is, and say Xe, that's xenon, because xenon has, let's see, xenon has a full p orbital. It has a p6. So you go to that last full p, okay, can't use that one because it's not full, and then you just write 6s2, 4f14, 5d10, 6p2, and that's the shorthand way. You can only, it has to be 8a, the one that was before it, okay, only that. And so whichever one you're doing, you go back to that one that's full, and then you write the rest of this, and that's called the shorthand electron configuration, because some of these that get really, really long, you know, you're going to have, you know, hand cramps and stuff like that by the time you get done. All right, so I've given you a couple of, oh wait, I'll do this one since it's an example. Write the orbital diagram. Now that what we were doing just then, right, was electron configuration, which is this 1s2, 2s2 thing. Orbital diagram is going to show how they feel. And so for this one, that we're doing sulfur. And the first thing you do is you go and you look and see what number it is. And if you look on your periodic table, it's atomic number 16, which means it has 16 electrons that you have to fill. Now, easy to do your electron configuration if you've been practicing it, right? But for the orbital diagram, if you're going to do it, you know, in order, then you're going to do 1s, then 2s, and then 2p. See, I'm doing it in the same order. Then 3s, 3p, right? So then I fill in my electrons using my Aufbau, my Hund's rule, and all that. So I put 2 in this and 2 in that, and then I fill these up one at a time, and then this one fills, and then that is 16, Okay, so then 17, 18, 19, no wait, no, 2, 4, 10, 12, sorry, that's 12, 13, 14, 15, and then 16. So how many unpaired electrons does it have? It has 2 unpaired. That gets important later. That's why I'm asking you to be able to do that now. Okay? And so then you get to practice on argon. All right, and that's electron configuration.